There are two ways that you can make new vectors from existing vectors. One of these is vector addition, and the other is scalar multiplication. In this video, we'll look at multiplying a vector by a scalar quantity. A scalar is just another name for a number. A scalar has magnitude only, no direction. For example, to multiply this column vector by the scalar 2, you simply multiply each value in the list by 2. The resulting vector is twice as long, but it still points in the same direction. The vector has effectively been stretched. A scalar quantity need not be a whole number. In this example, the vector is multiplied by the scalar 1.5. Again, the direction remains the same, only the magnitude has changed. If a vector is multiplied by a scalar less than 1, the direction remains the same, but the magnitude is smaller. A scalar can also be a negative number. So multiplying a vector by -1 results in a new vector of the same magnitude but pointing in the opposite direction. Scalar multiplication by any other negative number would reverse the direction and also change the magnitude. Algebraically, we can express scalar multiplication of two-dimensional vectors like this, where c is a number. Generalizing for any number of dimensions n, we can write this. Multiplying vectors by scalars has a number of applications, particularly in physics. For example, the famous English scientist and mathematician Sir Isaac Newton recognized that if an object with a particular mass is accelerating in a particular direction, then you can calculate the force it will exert when it runs into something, or indeed the minimum force required to stop it moving, by multiplying its mass by its acceleration. The mass of an object is a scalar quantity, whereas acceleration and force are vectors. Therefore, doubling the mass of an object for a given acceleration will double the force required to stop it.